In this module, we're going to put marginal cost and marginal revenue together in order to come up with an explanation. That is, how is it that a profit-maximizing firm chooses its quantity of output? Hence the title, Choosing Q to Maximize Profit at a Competitive Firm. So as I say, we need to put together marginal revenue, which we developed a few modules ago, with marginal cost that we saw in the last module to get the profit-maximizing quantity of output. The idea is kind of simple. A competitive firm maximizes its profits by its choice of quantity. And to do so, it wants to raise its quantity of output as long as marginal revenue exceeds marginal cost. So let's think about this. Suppose you were to produce another unit. Well, you'd get some additional revenue. That's the marginal revenue. And remember, at a competitive firm, the marginal revenue is just the price of output. You'd also incur some additional cost. And that additional cost is the cost of making another unit, or the marginal cost that we encountered in the last module. Well, if the additional revenue associated with this quantity, which is always just P for the competitive firm, exceeds the additional cost, which is the marginal cost of this quantity, then profit's rising, so you'd want to produce more. It kind of reminds me of that old Henny Youngman joke about, "Doctor, it hurts when I do this." Well, then don't do that. Well, it helps if I do this, then I should go ahead and do it. And in this case, helping is generating revenue in excess of cost and therefore increasing profit. So if we put costs together with revenue, we can find how profit varies with output. Let's take a look at some familiar pictures. On the left-hand side here, we have the total cost curve that we encountered before. It's that usual shaped TC curve. Over here, we have total revenue as a function of quantity. So this total revenue is just P times Q, because remember, the price is constant no matter how many units of output the competitive firm produces. If we put these together in the same picture, we can get an idea of what the firm wants to do. So here we have that ray, which is the total revenue function, and the TC, the total cost curve of its usual shape. Now notice that profit is the vertical distance between revenue and total cost. So if we think back to what the question is here, the question is, what quantity of output should the firm produce to maximize profit? Well, the firm wants to find the quantity such that the vertical distance between the revenue curve and the cost curve is maximized. We could also make a picture, and here we have made a picture of the difference between revenue and cost, which is profit. Now I've blown it up and changed the scale so it looks like profit's enormous, but the point is this vertical distance between revenue and cost ends up being this figure that rises and then falls and reaches a maximum at some particular quantity, and that quantity is the answer to our question, how much should the firm produce? Let's just make sure we have complete clarity about what's going on. So if you think about that total cost and total revenue picture, now what I've done here in this diagram on the left is I've kind of blown up a little portion of it. So think about, suppose we're at the quantity of 10 units of output. At 10 units of output, turns out that revenue is $300, and cost is $210. Now imagine we were to increase output by 1 unit to 11. What happens? Revenue goes from 300 to 330. Revenue rises by 30, but costs rise from 210 to 232. Well, that means that revenue is rising faster than cost, and so increasing output from 10 to 11 would raise profit. So that means we'd like to increase output beyond 10 toward 11. What about if we were at a quantity of 20? Well, at a quantity of 20, the revenue would be 600. If we were to increase the output by 1 unit to 21, revenue would rise by 30. Notice it's the same 30 it rose by when we increased output from 10 to 11, because for a competitive firm, the marginal revenue is just the price of output, which it has no control over, so it's constant, in this case at 30. What would happen to cost, though, if we were to increase output from 20 to 21 units? Well, costs would rise from 520 to 562, or by 42. Revenue went up by 30, costs went up by 42, so, oh, wait a minute, profits are falling if we were to increase output beyond 20. So indeed, we want to decrease output to less than 20. If we just step back, if we make a picture with total revenue and total cost, and we find that spot where the vertical distance between total revenue and total cost is maximized, here we have it where that vertical line is. Now, there are a bunch of special things about that quantity. Let's talk about those special features. One thing is that the change in revenue equals the change in cost at that quantity. So another way to say that is that the slope of the total revenue curve equals the slope of the total cost curve. Another way to say that is that at that quantity, marginal revenue equals marginal cost. And because this is a competitive firm, and remember, for a competitive firm, marginal revenue is just the price, that means that at that profit maximizing quantity that we typically call Q star, it's going to be the case that P equals MC. Because again, the marginal revenue at a competitive firm is just the price. Now we can do this whole analysis, finding the profit maximizing quantity Q star, which is where MR equals MC, in a different diagram, the average and marginal kind of a diagram, one where we live most commonly. So let's go ahead and do that. First, let's put together demand and cost. Now over here we have the firm's demand curve. Remember that a competitive firm's demand curve, and we talked about this a few modules back, it's just a horizontal line at the price. The competitive firm's cost curves, though, that we discussed in the previous module, have this, this flavor. This is a familiar picture to us with average cost, average variable cost, and marginal cost. Now let's put these together in the same picture. Just remember, though, what we're after here. We want to find that profit maximizing quantity, so we'll be looking in particular for the intersection of the demand curve, which shows marginal revenue, with the marginal cost curve. Let's go ahead and do that. So here what I've done is I've taken that right-hand side picture with all those cost curves, kind of a spaghetti of curves. I've added just one more curve to it, the firm's demand curve, which is, I think, kind of a dark mustardy color. Now, notice, remember that demand curve, it's a horizontal line at the price, and therefore it's also the marginal revenue. And look how it crosses that marginal cost curve, the gray curve. There's going to be something special about that point where it crosses. The quantity where marginal revenue crosses marginal cost is going to be that profit maximizing quantity of output. We can see a few more interesting things in this diagram. So one is we can see the profit. Now, let me talk about that. At that profit maximizing quantity of output, of course, the revenue per unit is just the price. The average cost per unit is the average cost at that profit maximizing quantity. And so that's what that level of that blue line is. What I've done here is I've filled in a rectangle to show the profit from producing the profit maximizing quantity. So let's talk about what that is. It's the price minus the average cost of producing the profit maximizing number of units, all times the profit maximizing number of units. We can talk a little bit of gory detail about that expression there. P minus AC of Q star is just the height of that darkened rectangle, and Q star is the length or the base of that rectangle. Now, we can ask an interesting question. Well, it's interesting to me, and I think it'll be interesting to you in just about a minute. In the short run, suppose a firm is making a loss. Should it necessarily shut down? And the answer, as implied by the heading of this slide, is in the short run, a firm making a loss should not necessarily shut down. How are we going to see that? What I've done in this picture is I put a demand curve in a slightly different spot. Everything else about it's the same. The cost curves are the same, but the demand curve, notice how it comes through this diagram, and it's below the minimum of average cost. So you already know that this firm's going to be making a loss, and so the first thought maybe they should shut down. But let's think about that. And remember, as we think about this problem, that the firm is going to be incurring its fixed costs regardless of how much it produces. So what this diagram tells us is that marginal revenue crosses marginal cost, where that demand curve crosses the marginal cost curve. And I've drawn in a vertical green line at that quantity. So just the naive application of the logic says that's the profit maximizing quantity of output. But at that quantity of output, the profit is actually negative. It's a loss. Why is that? Because the price is below the average cost of producing that quantity of output. So that rectangle that we see right there is the losses if this firm produces. But now let's ask the question, what if this firm didn't produce? How would its profits or losses compare to these losses? Well, remember again that this firm is incurring its fixed costs regardless of how many units of output it produces. So actually, there are going to be some losses if it doesn't produce too. And actually, we can see those losses in this diagram. Now remember that the difference between average cost and average variable cost is the fixed costs divided by quantity. That means that fixed costs are that vertical difference, that vertical distance between average cost and average variable cost times the quantity of output, which in fact is the collection of these two rectangles. These two rectangles together are the losses if the firm doesn't produce, and they're bigger than if the loss if the firm does. Gosh, so the firm should go ahead and produce even if it's losing money if the losses if it does produce are smaller than the losses if it doesn't. Let's talk about this one more way. I already said this, but let's say it again. Remember that fixed costs are equal to quantity times the average cost minus the average variable cost. And you can see that this collection of the two rectangles is exactly that. That is to say, it's the quantity on the horizontal axis times the vertical distance between average cost and average variable cost. So the firm loses its fixed cost if it doesn't produce, but it loses less if it does. And one final way to see that that's really kind of intuitive, notice that the price represented by the demand curve in this diagram, it's above average variable cost and it's above marginal cost. So the firm is making, up to the point where it crosses marginal cost. So these units of output are making incremental contributions to profit. It's just that these contributions to profit do not collectively cover fixed cost. They chip away at the fixed cost, so they reduce the losses, but they don't get all the way to the point that they cover all of the fixed costs. Now, what that means is, in the long run, this firm would like to shut down and stop incurring its fixed costs. But in the short run, it's already incurred those fixed costs, so the best you can do is to make back as much of those costs as it can. Now, one nice way to get clarity about how all this stuff works is to do a problem. So let's do this activity. Let's find the profit maximizing output for a competitive firm. In a problem like this, you need some givens. You need to know what the price is. You also need to know the firm's total cost curve. So here I've said that the price is 30 and the total cost function is 20 plus 10 times Q plus 2 times Q squared. I would also give you, and also will give you, the marginal cost curve, which here is 10 plus 4 times Q. And so the task generally is to find the profit maximizing quantity of output Q star, as well as the maximized profit. Well, we can do this with algebra. What are we trying to do? To find the profit maximizing quantity, we want to find the quantity such that MR equals MC. So that's what these equations are solving. MR is the price, it's 30, and MC is 10 plus 4Q. So if we solve that equation, we get 20 equals 4Q, or Q star equals 5. So this firm would want to produce 5 units of output to maximize its profit. How big is its profit if it produces 5 units of output? Well, revenue is the price per unit, 30 times 5, so it's 150. What's total cost? We can plug that quantity 5 into the total cost curve, and we get 20 plus 10 times 5 plus 2 times 5 squared for a total of 120. So the maximized profit at this firm is 150 minus 120, or 30. Here's the problem kind of summarized in pictures. On the left, we have total cost and total revenue. And on the right-hand side, we have the marginal revenue curve, which is the demand curve, and the marginal cost curve, and we see that they cross each other at a quantity of 5. I guess I could also note that at a quantity of 5, if you stare back at the total cost and total revenue curve, you could see that the vertical distance between revenue and cost is 30, 150 minus 120. So what are our takeaways from this module? Well, first of all, profit is equal to revenue minus cost. And second, the profit maximizing level of output, which we typically, output is in general Q, and the profit maximizing level we often call Q star. Anyways, the profit maximizing level is the level where P equals MC for a competitive firm. It's the maximum vertical distance between revenue and cost. It's also the place where the slope of revenue equals the slope of total cost. Finally, in the short run, a firm making a loss should not necessarily shut down. Remember, if there's no production, the firm loses its fixed costs in the short run. And if it does produce, if its profits are less, or if its losses are smaller than the losses if it doesn't produce, then it would like to produce anyways if it can cover its variable costs.